If your entire career is built around managing and protecting information, listen up, because we're going to talk about a technology that is set to completely rewrite the rules of your profession. I'm talking about quantum computing. And no, this isn't science fiction anymore. This is the new reality we need to prepare for.
To really get our heads around this, let's start with this powerful thought from the futurist Linda Shaw. This one sentence just perfectly nails the scale of what we're talking about. We're not looking at a simple upgrade here. We are staring at a completely new horizon.
So let's just dive right in. We're calling this the quantum wave for a reason. You know, it's like one of those massive waves that builds its power way out at sea. You might not see it coming at first, but when it arrives, it's going to reshape the entire landscape. And it's bringing with it some huge opportunities, but also some really urgent challenges.
And that's because this isn't just a new tool. You can think of it more like an ultimatum. For businesses, for governments, for any organization really, the question isn't if they'll have to deal with quantum, it's when. If you want to stay relevant, if you want to stay secure, a quantum-ready approach is not going to be optional. It's going to be absolutely essential.
Okay, so to really grasp why this is such a revolution, we need to get right down to the fundamental building block of it all. We have to go beyond the bit that we all know and love and start understanding the qubit.
This slide really lays it all out. A classical bit, right? It's like a light switch. It is either on or it's off. A 1 or a 0. Dead simple. But a qubit, well, a qubit plays by the bizarre, wonderful rules of quantum mechanics. It can be a 1, it can be a 0, or, and this is the part that changes everything, it can be both at the very same time. That amazing state is called superposition, and it's the secret sauce that gives quantum computers their unbelievable power.
And here is where that power just goes off the charts. You know, with our normal computers, you add more bits, you get a little more power. It's linear. But with quantum, every single time you add just one more qubit, you double the system's processing capacity. You add another one, it doubles again. This isn't just adding, this is exponential growth. And that's what unlocks the ability to solve problems that are just impossible for classical computers.
So this leads us to a really important new term for our field, quantum information processing. What is it? Well, it's basically everything we already do, you know, capturing data, storing it, securing it, but it's supercharged by all those quantum properties we just talked about. Think of it as our profession, just evolved for a whole new era.
Now, the really crucial thing to get is that this incredible power doesn't just stay locked up in a laboratory. Nope. It creates a ripple effect that spreads out and starts rewriting the rules for entire industries and maybe even for society itself.
And the reach of that ripple effect is just staggering. I mean, think back to how classical IT completely changed every part of our lives. Quantum is set to do that all over again. Just imagine designing new, life-saving drugs in a matter of days instead of decades, or optimizing global supply chains in real time, or creating truly unbreakable encryption for national security. Literally no sector is going to be left untouched.
Let's just focus on security for a second, because it's the perfect example of quantum's double-edged sword. The threat is very real. A powerful enough quantum computer could, in theory, smash the encryption that protects everything from your bank account to top government secrets. But, and this is the really wild part, the same weird physics that creates the threat also gives us a solution. Quantum cryptography lets us create brand new, ultra-secure protections that are based on truly random keys, promising a whole new age of data security.
Okay, so with that big picture in mind, let's bring it right back down to the core challenge for us as information professionals. All this power, all this complexity, it creates a huge problem. Our current record-keeping methods are simply not designed for this new reality, not even close. First off, there's the data itself. A normal digital file is pretty stable. But quantum information? It's incredibly fragile. I mean, the slightest little vibration or temperature change from the outside world can make it, well, decohere. It collapses from that rich quantum state back to a simple 1 or 0, and poof, all that special information it was holding is just gone. So our first challenge is figuring out totally new ways just to keep a quantum record safe over time.
Second, there's the process. Think of it like a recipe. If you want to trust the cake at the end, you need to know the exact steps that went into it, right? In quantum computing, these steps are called gates. They're the tiny little operations that manipulate the qubits. We have to keep a perfect auditable log of every single gate applied to every single qubit in the exact right order. If we don't, the results just can't be trusted or repeated.
And third, the blueprint itself becomes a key part of the record. The actual design of the quantum circuit, you know, how those gates and qubits are all wired up for a specific problem, that's a critical piece of information. If you want to understand or audit the calculation later, the circuit diagram has to be preserved as a core part of the record.
And finally, it's not even just about the quantum process itself. We need incredibly detailed records of the entire ecosystem around it. The normal computers that are doing error correction, how the results are processed afterwards, even metadata about what specific machine was used and what temperature it was running at. All of these pieces have to be there for the record to be complete and trustworthy. So we've talked about qubits and circuits and all this tech, but honestly, the biggest and most immediate challenge that we're facing isn't technological. It's human. The biggest gap right now is in our own collective knowledge.
73%. Just take a second and look at that number. In the context of everything we've just talked about, what do you think that number represents?
That number? That's the percentage of Australians who, according to a recent government report, have never even heard of quantum technology. And as the minister points out, this isn't just a fun fact for a trivia night. This low level of literacy is a direct threat to a country's ability to innovate and compete on the world stage.
And this gets to the absolute heart of the matter. The way forward isn't just about hiring a new wave of quantum physicists. It's about empowering the incredibly experienced professionals we already have, the people who have been managing our information for decades, and giving them the foundational quantum literacy they need to lead us into this new era.
So where does this all leave us? You know, this isn't about having all the answers right now. This is a call to action. It's time for the entire records and information management profession to start having a serious, and I mean serious, conversation about the path forward.
We need to start asking some really hard questions. For example, our core standard for managing digital records, ISO 15489, it was built for a binary world of ones and zeros. Is that standard even remotely prepared to handle information that can be a 1 and a 0 at the same time?
And what about our really futuristic ideas, like DNA storage? That whole concept is based on translating a simple 8-bit string into genetic code. What on earth do we do when the information we're trying to store is fundamentally more complex than anything a simple binary string can represent?
And that brings it all back to us, to people. This is not a problem for somebody else to solve. How do we, as a profession with more than half a century of deep expertise, take the lead? How do we partner up with government, with industry, to build the quantum training programs that our people so desperately need?
The questions are on the table. The challenges are massive, no doubt. But so is the opportunity. For every information professional out there, the future of our entire field is waiting for us to write it. And that discussion, that work, it starts right now.